Hi, my name is Gina, and I am doing my video today on testing the differences between means with large independent samples. So, two samples are independent if the sample selected is not related to the other sample selected. Two samples are dependent if the sample selected corresponds with the other sample selected. For example, the blood pressure has been taken of 20 adults that have taken a sample medication. Is this independent or dependent? This is dependent. All 20 adults have taken the same sample medication. Another example is the blood pressure has been taken of 10 adults that have taken a sample medication and 10 adults that have taken a placebo. Is this independent or dependent? This is independent because 10 adults were given the sample medication and 10 were given the placebo. Hypothesis testing for independent sampling. The null hypothesis, H sub 0, usually states that there is no difference between the parameters of two populations. It always contains the following symbols: less than or equal to, or greater than or equal to. The alternative hypothesis, H sub A, is true when H sub 0 is false. It always contains the following symbols: less than, not equal to, or greater than. For a two sample z-test, the difference between means, the samples must be randomly selected, they must be independent, and the sample size must have a normal distribution that is at least 30. A two-sample z-test can be used to test the difference between two population means, mu sub 1 and mu sub 2. The test statistic is given by the following formula. You have x bar sub 1 minus x bar sub 2 minus mu sub 1 minus mu sub 2 over sigma x bar sub 1 x bar sub 2, where sigma x bar sub 1 minus x bar sub 2 equals the square root of sigma 1 squared over your sample population 1 plus sigma sub 2 squared over your sample population 2, and you're going to take the square root of that number. Sorry, this isn't the easiest formula to say. So for example, a nutritionist is interested in whether two diets work equally well for customers. In order to assess a difference between the diets, the nutritionist puts 50 customers on one diet. Those customers lost an average of 11 pounds with a standard deviation of 3 pounds. 60 customers were put on the second diet. Those customers lost an average of 8 pounds with a standard deviation of 2 pounds. Do the diets differ in terms of their weight loss? Use alpha equals 0.01. So first, you want to state your null and alternative hypothesis along with the claim. So looking back at the problem, you can see it's asking if they differ. So we're going to say that your null hypothesis is mu sub 1 minus mu sub 2 equals 0, and your alternative hypothesis is mu sub 1 minus mu sub 2 is not equal to 0. And since we're trying to see if they differ, we're going to say that your alternative hypothesis is your claim. So next you want to look at all the information that is important. So we see that your X bar for your first diet is 11, and your X bar for your second is 8. Then you see your standard deviation for your first one is 3, and the standard deviation for your second diet is 2. And the population for your first diet is 50, and your population for your second is 60. And then we see that alpha is 0.01. So now you want to find your critical value and your rejection regions. So you know that alpha equals 0.01. So you want to take 1 minus 0.01 to get your level of confidence of 99%, 0.99. So I just showed the chart of the most common confidence levels along with their z-score. And you can see that 0.99 has a z-score of 2.575. And since your hypothesis is equal to and not equal to, we're going to say that it's two-tailed, which is why there are two critical values. You have your negative 2.575 and your positive 2.575. So your rejection regions are written as z is less than negative 2.575 and z is greater than 2.575. Now to show this on your graph, you would start by knowing your critical value and your rejection regions. So here's your chart. You see that your first critical value, your negative 2.575, lies around there. It's not exactly equal, just a little bit by sight. And your positive 2.575 is on the other side. So now it says your rejection region is less than negative 2.575. So this would mean that that is your first rejection region, and your other rejection region is greater than 2.575. So that would be your second rejection region. Then you want to find your test statistic by using the formula. So first you want to plug in all the information that was given earlier. And this is what that will look like. And then you want to solve. So 11 minus 8 minus 0 equals 3. 3 squared over 50 plus 2 squared over 60 with the square root is 0.4967. When you divide that, you get z equals 6.04. Then you want to see if your z is in your rejection region. So you have that z is 6.04, and you want to look back at your chart, and that lies around there, we'll say. So since 6.04 lies in your rejection region, you're going to reject your null hypothesis because there is enough evidence to reject the claim that two diets differ. I'm sorry, that's supposed to be support. There is enough evidence to support the claim that your two diets differ at the 1% significance level. And that is it. I hope you enjoyed.